So why are these changes happening? The Earth is warming due to an increase in greenhouse gases in the atmosphere. Sunlight radiates towards Earth. Some of that sunlight hits the Earth and is reflected back out into space. Most of it, however, is trapped by the layer of greenhouse gases. The higher the concentration of greenhouse gases, the more heat that is trapped. Some people might describe this as the pickup truck effect. If you picture a truck parked in the sun, it will be much warmer inside with the windows closed than the outside, even in winter. So why does this happen? Shortwave energy from sunlight can get in, and when the solar radiation strikes the inside of the truck, much of it turns into long wave heat energy that gets radiated back. Those longer waves can't get back out through the glass, and the truck gets hot. Greenhouse gases in the atmosphere act like the glass of the truck window, and we are all sitting in that truck. What are these greenhouse gases and where are they coming from in the US? The four greenhouse gases that have the highest concentration in the atmosphere are water vapor, carbon dioxide, methane, and nitrous oxide. Over half of the greenhouse gases being emitted into the atmosphere are coming from transportation and electricity generation. In agriculture, the majority source of greenhouse gases comes from agriculture soil management or nitrous oxide emissions from fertilizer. Enteric fermentation and manure generated by livestock are the next highest sources of greenhouse gases. For at least the last 2,000 years, carbon dioxide, methane, and nitrous oxide concentrations in the atmosphere were pretty level. The vertical pink line marks the year 1880. At the end of the 1800s, levels of greenhouse gases began to skyrocket as more carbon was taken out of the earth in the form of coal, natural gas, and oil, burned, releasing them up into the atmosphere. As our need for energy increased due to manufacturing, the invention and then widespread use of electricity, the introduction of the automobile, and the introduction of fertilizers, more and more greenhouse gases were emitted. If we look back over the last 800,000 years, scientists know from ice core data that the levels of carbon dioxide in the atmosphere never reached above 300 parts per million prior to 1950. Since 1950, carbon dioxide levels have risen dramatically. In fact, half of all human-related carbon dioxide emissions occurred only in the last 40 years. The current level in 2020 is 414 parts per million and rising. The annual rate of increase in atmospheric carbon dioxide over the past 60 years is about 100 times faster than previous natural increases, such as those that occurred at the end of the last ice age, 11,000 to 17,000 years ago. To get a sense of how much carbon dioxide levels have increased in your lifetime, click on the link below to see how many parts per million of carbon dioxide were present in the atmosphere the year you were born. The rise in carbon dioxide levels since 1880 directly correlates with the rise in average global temperature. We know that increasing greenhouse gas concentrations in the atmosphere is making the planet warmer, but why are we seeing wetter conditions in most places? As temperatures increase, more evaporation occurs and there is more water in the atmosphere. This creates clouds, which increases rainfall. More moisture in the atmosphere also increases temperatures because water vapor is a greenhouse gas. Warmer air also holds more moisture, thus creating this cycle. Despite all this alarming information, there are reasons for hope. Knowing that climate change is human-caused means that we as humans can fix this. In the US, we've made some positive changes over the last 15 years. The US reached peak greenhouse gas emissions in 2007, and we've been going down ever since. A major contributing factor to the decrease in emissions is the decreased use of oil and coal-fired power, while renewable energy and more efficient natural gas use has been increasing. In 2020, the reduction in travel and economic activity caused by the coronavirus outbreak is reducing emissions by more than 8%, the largest annual decrease ever recorded. Renewable energy is predicted to grow by 5% this year. Here at USDA, in addition to the climate hubs, there are many initiatives and resources available around the topic of climate change and weather variability. NRCS programs such as the Environmental Quality Incentives Program, or EQIP, and the Conservation Stewardship Program, or CSP, fund conservation on landscapes. When tied to educational information developed from the Soil Health Program and technical assistance from local NRCS conservationists, we are able to assist producers in building healthy, productive, profitable farms and ranches that are resilient to weather extremes. This slide highlights some of the many resources available from USDA. Another thing that brings hope is that different farming practices can help farms be resilient to weather volatility. Many actions that improve natural resources not only strengthen the farm in the short term, but will also help store carbon in the soil and decrease greenhouse gas emissions in the future. Some farms may also choose to adapt by increasing infrastructure such as high tunnels, irrigation systems, and inputs such as fertilizers and pesticides. However, many of these types of actions are expensive and don't address the root cause of the problem. For this presentation, I will focus on ecological planning and improving natural resources. A lot of these practices may be familiar and are the same for improving soil health. For more information and to sign up for the Northeast Climate Hub's quarterly newsletter, please visit our website.